Alright, this video is going to take a look at vertical and horizontal lines. They're a little bit weird, not going to lie, they're kind of strange. One of the things to kind of keep in mind is what's happening behind the scenes. So sometimes it's a little easier to see the picture and then use the picture to come up with, well, what does that look like then? What's the structure behind the equation? What kind of variables do I need? Alright, so let's go ahead and give a couple of examples here. Let's start with the horizontal line. For some reason, that just inherently seems easier for people. So here we go. We have a horizontal line. So if we started naming points on this line, we notice that, well, here we have -8, 5. And then over here at this point, let's go ahead and change colors on that. Let's have -5, 5. And then let's see. Then we have -1, 5. I'm sensing a pattern. And then we might have apparently a different color. We might have something like 3, 5. You know, something funky's happening with Y. It always seems to be 5. Then the question is, well, what's X? Kind of can be anything it wants, it looks like. So, horizontal lines. Do they have a Y value? Yes, they do. It's constant. So we know that it at least equals 5. But then we're going to ask how it changes with X. Does it change? Doesn't seem to. So, alright, well, if there's no change, then that means that there's no slope. But 0 times X is just 0, so it turns out that this is just Y equals 5. That's it. And there's the equation. That's technically in slope-intercept form, by the way. But if you take a look at all horizontal lines will have the format of y is equal to a. A is whatever number it's passing through. Whatever the y coordinate is of that line, that's the value of a. You just stick it in there. It's a little bit weird. I kind of relate the vertical and horizontal lines to a breakup. So if you've ever had an ex-girlfriend or an ex-boyfriend, or you know, God forbid, an ex-husband or ex-wife, that sort of thing, think about this in kind of that regard. So your Y, you're just kind of doing your thing, just cruising along. What's your ex doing? Do you care? It's kind of the way that the horizontal line feels. It's like, I'm going to do my thing. What's my ex doing? I don't give a shit. I really don't care. So, there you go. What's X doing? Anything it wants. Don't have a care in the world. That's kind of the way I viewed it. I don't know why that came across to me as like, it's like a breakup song. Maybe somebody could make a song about it. Vertical lines. Vertical lines work the exact same way. Only, if you take a quick look at them, let's go blue. We'll come over here where it's a little cleaner. Instead of y not changing, the x values don't change. So 8, 3, 8, 0 maybe. 8, -3. That sort of thing. And so if you notice, that x value is not changing. Well, we can still write an equation for it. We can say something to the effect of, well, x is equal to 8, and then we're going to add in the change on the y. Well, what is y doing? I don't know. it's apparently changing, I guess. So it's a little bit funky this way. We notice that, what's the rate of change as far as, now, because we're starting with x, we're looking at the rate of change left and right. So does it wiggle? No, it's just straight. It doesn't move left or right at all. Okay, well then it gets a zero slope as far as our left to rightness. And how does y change? Well, it changes because it's a y value. Alright, so in that case, x is equal to 8. And there it is. So now, is this in slope-intercept form? And the answer is no. No, it's not. Not even a little bit. If you were to calculate the slope of the horizontal line, because it's in this format already, you would come up with a slope of 0. In fact, we can just take a couple of examples. So let's take, negative 8, 5 and negative 5, 5, and we'll calculate the slope. So 5 minus 5 over negative 8 minus negative 5 is equal to 0 over negative 3, which is just 0. It has a slope of 0. Now, it's not quite the same with the vertical lines. If we were to take a look at the slope of the vertical line, then we would notice that we have something. Let's take 2 points like 8, 3, and 8, 0. It's just easy. So let's take 3 minus 0, and then let's take 8 minus 8, and then we're going to notice that we get 3 over 0. What's that? It's not 0. So just as a refresher, this is undefined. The slope of a vertical line is undefined. And it's also, by the way, in this whole ex-boyfriend, girlfriend, wife, husband thing, you're now in the perspective of your ex. It's like, what does your ex care about what you're doing? They don't. Well, unless they're a stalker. Then maybe, yeah. So maybe like the weird lines are stalker-ish. Maybe that's the thing. But anyway, they're not caring what you're doing either. So it doesn't wiggle in that direction. But this is the idea behind horizontal and vertical lines. Not always will lines have intercepts in both the x and the y axes. In this case, if you have a horizontal line, it won't intersect the x-axis unless it is itself the x-axis. In a vertical line, it will not intersect the y-axis unless it is itself the y-axis. That's it. That's all that horizontal and vertical lines do. All right, well, I hope this helps. Keep in mind, it's actually useful. It is.